In this rather short video, we're going to have a look at debugging and to present a few suggestions or rules of thumb that, if we follow, generally speaking, should help us with the debugging process. Debugging is something that all programmers have to deal with, and it's also a skill that's learned, so it's something that can be improved over time. But it is important to adopt a systematic approach to hunting down and to resolving bugs within a program. And we're going to look at sort of 10 pieces of advice that really apply to any type of debugging. But I want to highlight first of all that within games, debugging sometimes can be quite challenging and quite difficult. So games are not the easiest of entity to debug, and there's a couple of good reasons for that. The first one is that things happen quickly within a game. We're looking at running our update and our draw loop 30, 50, 60 times a second. So at that particular resolution from one update to the next, things are happening faster than we can sort of easily perceive. So in terms of something going wrong in the game, we visually might miss it, or we might have a problem that creates a knock-on effect into the next frame, into the next frame, into the next frame. And it maybe takes us 1/10 of a second to realize something's going on, and that's potentially 5 or 6 frames after it actually occurred in the first place. So a lot of the debugging within games is us inferring what is likely to be the problem from what we actually are capable of observing. And that means that we do have to reason, and we have to think about from one frame to the next how an issue or a problem might evolve or to change things over a period of time. Second reason, which doesn't necessarily apply to types of projects that we're doing, if you're developing particularly, for example, a 3-dimensional game, you'll have a lot of elements which are running on the GPU, some in the CPU, and again, it can be that there are nice debugging tools for looking at what's happening in a GPU, but it's not as convenient as having, say, a debugger that is nicely built into our environment, but not really an issue for us on this particular module. So what we're going to present here are 10 rules of thumb, sage pieces of advice that if you follow them and make sure you sort of do adhere to them, they will help you with the process of debugging your game. So we're going to start off with 10 of them, no particular order, so all of them are really as important as any other one. So the first of our commandments are, thou shalt have a clear understanding of what should happen. And always, I suppose, surprises me how frequently that isn't the case. That when you're talking to somebody, and you ask them, okay, well, what should it do? What do you want the functionality to be? They're not able to describe it precisely or say exactly what it is they are looking for in terms of the functionality. They might have something in their mind in terms of it should look like this or it should do that. But if you can't precisely say what it is the expected output is, then that's going to make your debugging life considerably more problematic. So you should necessarily have a clear understanding of what that piece of code should do, of what constitutes a correct working answer and what constitutes a wrong, invalid answer. And if you don't have that understanding, then it is wrong to try to debug it. You should go back, you should understand what is right, what is wrong behavior. That's what you need as your foundation in which to meaningfully debug. The second commandment is, thou shalt reproduce the problem consistently, if you can. Not always possible, but where possible, you should try to have a repeatable series of events that if we do this type of input and have this type of thing set up this way, then it crashes under these particular conditions. Because that enables you to have something that is repeatable. You can then consistently generate the problem, and that gives you a chance then to test out different reasons or to explore different aspects of it. Sometimes you can be unlucky and you can have crashes which seem to occur at random. Quite often these sort of memory related or some other dependency on it. They can be a lot more nasty to debug because they're not as repeatable. And there you're looking at, well, what information you can log to help you understand what was the issue when the bug occurred. Third commandment, thou shalt test your assumptions. This is a hard one to do. Fundamentally, if you understand what is right and what is wrong within your program, debugging comes down to testing assumptions. So you might assume that, okay, this object will never be null, or the value that we enter in will always be positive. Now, these are assumptions which may be invalid, and we want to test to see that if the things that we assume need to be true for the thing to be running correctly, if those assumptions actually are being met. And it's difficult because very often these are things that we assume. We don't necessarily sit down and define them explicitly. We can sort of take them for granted. And a bit of debugging is almost sort of to realize that, oh, I'm assuming this is the case, but is it actually the case in terms of how the code is being executed? Thou shalt divide and conquer. That's fundamentally how debugging works. That if you're given a problem, you sort of reason and ask questions. Okay, is it in this bit of the project? Is it this set of classes? Is it this particular one? You're all about trying to narrow down the search area so you can home in on where the bug is. So you want to set up tests initially that will enable you to discard bits of it and then focus in until you're down to the specific area where you suspect the bug is going to be found. Next one, after that, thou shalt think and look. So as mentioned, this sort of ties into the one on identifying your assumptions. You should ponder, you should say, well, it could be this, and for this reason it might be that. Whenever you've said that, it's then important to go and to test your assumption, to use the debugger to put in a breakpoint, to log something out to a file, to use some other means of actually testing your assumption. So it is important to come up with assumptions and to test to see if those assumptions are true in terms of how the program is executing. I shall change one thing at a time. And that's useful advice, that if you think, well, it could be this, or it could be that, don't change them all at the same time. That increases the risk of something going wrong or not be able to untangle them. Change one, test it. If it's not that, change another thing, test it, and repeat until you find the bug. Thou shalt keep an audit trail. Sounds a bit boring, but in essence here is useful. If we're using code versioning through SVN or Git or something like that, we almost have an audit trail built in. So what that means is that if on Friday it was working perfectly fine, and now on Tuesday it's not working okay, if we have a good audit trail, we can check back to see what was introduced since the last time it was running to now, and that helps again immensely narrow down, well, what might be the trigger or the area in which it was problematic. Thou shalt thoroughly test the correction. It's important not to under-infamous how important this is. So there, when we're thinking about testing it, if you get it running and it seems to work okay, you need to thoroughly test that that is the case. So think of all of the other conditions that could go wrong. Importantly, when you introduce the fix, there's a risk that you might then have broken another part of the program. So it's important then to go and to test all different areas to make sure that they too are continuing to work. And I believe it's the final one, or maybe I shall not let the problem remain unfixed. Often debugging can be a bit of a chore, and if you're sitting doing development, adding on nice new functionality, it may appeal more not to worry about this bug that occasionally kicks in that maybe we could work around, and it's better then to focus on adding new shiny things into it. Almost always a bad idea. It comes under something known as sort of technical deficit or debt within your project, that when a bug is introduced, if you leave it, it is likely that in the future the impact of that bug is going to become more serious, or it's going to be more difficult to resolve it. So whenever a bug is detected, that is the right point in time to work out what it is and to fix it before the complexity of the system increases, and that makes it more difficult then to fix it. So key takeaways in this, there is only sort of a couple of ones here. A clear understanding of how the program should work is essential for effective debugging, and it is. So you should understand precisely what behavior you are looking for, what constitutes correct behavior, what constitutes incorrect behavior. If you don't have that, there's no point debugging. The second one then, if the reason of the bug is not apparent, then effectively we are into a divide and conquer approach, where we are asking questions, we reason it's probably in this area or the reason it's not in that area. We test that assumption. That enables us then to narrow in on the bug, and we repeat the process of making an assertion about it could be this or it may not be that, testing it and repeating until we narrow down to the actual area, specific area where the bug is found. So hopefully some useful advice. As mentioned, debugging is a skill. The more you do it, the better you get at it, but it is most certainly in your interest to try to debug in a systematic, planned manner.